Good afternoon, ladies and gentlemen. Welcome to the final session of the day. My name is Dr. John Pearson. I'm the head of the Department of Textiles at the University of Huddersfield, which is in the north of England. This afternoon's session is to do with fashion and apparel, and it's very good to see that the Textile Institute is giving prominence to these areas, which are becoming more and more important as distinct from its traditional areas of textile technology. And we have 4 very interesting papers this afternoon. I'm sure you'll find them very stimulating. The first paper is to be delivered by Dr. Traci May-Plumlee, who's Associate Professor at North Carolina State University, who is talking on an integrative process for design and development of functional apparel. Now, we might say that all apparel is functional and that it keeps us warm and protects us. But nowadays, it's such a diverse aspect, trying to integrate more and more properties and such a wide range of criteria involved with designing and developing apparel. I'm sure it'll be very interesting to see how Dr. Plumlee is approaching this. So, up to you.
Thank you. We sometimes tend to think of design, particularly when we think of apparel design, as some kind of nebulous, sort of mysterious process where a designer disappears into some private space for hours or days or even weeks and somehow emerges with these wonderful items for a product line. And although design is a very creative process, it's certainly not always the mysterious and completely intuitive process that we sometimes imagine, and that it's often perceived to be. In fact, design of any sort requires a problem-solving approach and definitely consideration of performance requirements. Even for the most aesthetically pleasing and creative kind of apparel piece, there are still a given number of performance kinds of requirements that we must consider in the process of creating a product. So, given that, before I go any further, what I'd like to do is take just a moment and talk about the idea of what is it that I mean when I speak of functional apparel. Because we do think of apparel as a functional product, and in fact, we know that it is. All apparel is functional to a degree. When we think of clothing, it has to be supported by the body. We have to be able to wear it and that it will stay on and conform to an extent to the body. And it also needs to allow some degree of body movement. So when we think of these things, it's apparent that all apparel is functional. So what is it that's unique, and what is it that I mean when I talk about design of functional apparel, or the idea of functional apparel per se? What I'm really thinking of is apparel items and products where performance requirements dominate over the aesthetic requirements. I find it helpful to envision products as kind of falling someplace along this continuum that helps us to envision how those aesthetic and functional performance requirements balance in the product. I've put a couple, actually 3 examples of products on here to kind of use to talk about this concept. You'll notice that the evening gown falls very near the aesthetic end of the continuum. This would indicate that this is a kind of product that has very involved kinds of aesthetic requirements, and the aesthetics are very important. The visual appearance, the tactile sensations, these sorts of things. If we think of something like the business suits we wear day to day, we might envision them as being somewhere more in the middle of this continuum where a real balance is needed, where we have some concerns for aesthetics and we want to look nice and we want to enjoy the fabrics. But on the other hand, we also need to be able to wear these things all day, every day. We may need to pack them and travel with them. So there's a real balance of requirements there. And then there are products that tend to be dominated by the more functional end of the spectrum, or the performance kinds of needs and requirements. And I've used a surgical gown as an example here. When I say surgical gown, I'm thinking of the kind of covering that a nurse or a doctor would wear into the operating theater. When we think of this kind of product, the surgical gown, certainly there's a major functional requirement that comes to mind immediately, and that's the idea of this barrier function, the idea that the surgical gown creates a barrier between the doctor or nurse and the patient. And it's kind of a two-way barrier in that we don't want bacteria and fluids from the physician or the nurse to contaminate the patient, and particularly in a surgical wound. But on the same way, we don't want the fluids that are released during surgery to contaminate or be exposed to the nurse or the surgeon. So we have that very important barrier function. But we also, if we think about it, find that there are numerous other kinds of functional or performance sorts of requirements that have to be addressed by a design for a surgical gown. Certainly I don't claim to have an exhaustive list here, but I want you to begin to see how many kinds of requirements must be addressed by a design when we begin looking at a functional sort of product. Durability can vary much depending on whether we've got a disposable product or a multi-use sort of product. Cost is very important for this kind of product. So already as we begin to look at this list, we can see that there are a number of competing, even requirements that seem exclusive of each other, that if we address one, we will be working contrary to the others. So because of this, and because this situation arises, particularly when we look at the kinds of products that I would think of as being functional apparel, we really need some kind of process that will allow us to optimize some combination of design features that will best address these design requirements. To do so is not a simple task. It requires a holistic kind of approach, looking very broadly at the design problem. It also requires a very in-depth analysis of these wide variety of even competing design requirements. And it needs to be an analysis that will allow us to not only visualize, but also organize and prioritize these requirements as we move into the design process. That said, I'd like to share a little bit of background with you in terms of where my approach sort of has grown from. There are some traditional apparel design approaches. There are many more that I'll mention here, but there are a couple that I'm going to pull in just because I think there are key ideas here that I've built on. Orlando in 1979 presented a 7-step process for design of apparel. And one of the key ideas or key components to this process was the idea of objectifying design, making it an objective and critical process so that it couldn't be so easily distorted and swayed. Watkins, in her text, The Clothing, the Portable Environment, described this process in 5 stages, and the strength of her approach really lies in the idea of analysis being a starting point for the design process. So these are traditional apparel design kinds of approaches. One of the things that becomes a challenge with these approaches is that even though they have strategies for beginning to gather these requirements together, they don't have a really very constructive or concrete way to begin to organize and prioritize these requirements. There's been some work done, something they call an interaction matrix, to begin to work this way. But here's where we can take a lesson from industry, looking at a design tool called quality function deployment that some of you may be familiar with. It's a way of addressing a variety of competing requirements, usually in designing a product to reach a market. A very customer-driven process. I'm going to use the fancy pointer. If you'll particularly observe these first 2 areas, these first 2 houses are the ones that I would use primarily for the design process. What they allow us to do is translate customer requirements or customer needs into design attributes, then translate those attributes into product features. So building on these 3 approaches, it's really been an integrative design process that's been pulled together here. It's really a disciplined approach that needs to be undertaken ideally by a design team. I see it as containing 4 major thrusts. You'll notice the first 2 are really consistent with this approach I mentioned from Watkins, looking at analyzing materials and analyzing design, and then moving into the design development. And always there's an evaluation component when we look at a design. We need to find out if we're successful in addressing these needs. Materials analysis. We're talking about doing things like examining potential raw materials, looking at using existing test methods to evaluate those materials, and then to even assess the effects of construction on the performance of those raw materials. If we look at the surgical gown example, seams can be stitched, they can be ultrasonically welded, they can be glued, they can be developed in any number of ways, and we need to know how that will impact the product. Note that the properties of interest will vary depending on what the end product is, and it's very important that the relevant aspects are the ones that are tested and evaluated at this point. Design analysis. Looking at a study of the end user as well as any existing products that might be out there that utilize or are used for the same kinds of purposes. Looking at sizing and ergonomics, or the relationship between the body and the product, is an important part of this. Looking at fit of existing garments. Sometimes fit can be a major issue that hasn't been addressed in the past. I find that looking at strengths and weaknesses of the existing products can be very useful. Perceived requirements as far as the end user is concerned can provide valuable insights into developing a product that will address these needs and requirements. There are 4 strategies here that I find very useful. We're going to talk about them a little more extensively in my example, so I'm not going to detail them here. And sometimes we even involve laboratory testing using copper mannequin, or doing wear testing even with individuals. Because the sizing, fit, and ergonomic analysis is something that's critical and we may not be as familiar with, I did want to show some examples of both high-tech and lower-tech ways that we might look at how the body moves and how the measurements of the body are and what we need to fit. You see an example of a point cloud from body scanning, some simplified ways of using angles to describe body movements, using existing garments to determine how a garment must change when a person moves, and actually drawing measurements from the body scan are all strategies that we might use to analyze size and fit, and that ergonomic approach. Design development. I really think of this as occurring in kind of 2 steps. We've spent all of this time analyzing and looking at the materials and looking at the end user and the end uses of the product. And so now we've got to begin to figure out a way to pull this all together. So analyzing and prioritizing requirements through the use of a grid sort of structure, the QFD House of Quality is the one I've adopted to use. And then we begin to create design solutions to address those prioritized requirements. And again, I want to emphasize that for many products, it takes the combined expertise of multiple researchers to actually accomplish that. And then finally, there's an evaluation stage. It may involve evaluating individual components along the way. It may not be the case that we end up with the finished product before we're ready to evaluate. We may be evaluating seam structures along the way. We may be evaluating individual components. We may need laboratory testing to evaluate the product. In the case of something like a surgical gown, that barrier performance cannot be sacrificed for improvements in design. So this is something we may need to use. Laboratory simulations and human wear testing may also be undertaken as a way of evaluating the designs. So this is in a nutshell the process. It's a little abstract at the moment, so I want to walk you very quickly through an example. I know my time is limited. But one of the things I've done to apply this is to look at developing a carpenter can, particularly for use for carpenters that do detailed and finished work inside of a finished building where there's lots of things that they could easily damage with tools, and that it's awkward to carry lots of tools around and have them handy. So looking at this as a design problem, there are several analysis strategies that were adopted to begin to study the problem and study the situation. Now, as an aside here, you won't see any reflection of the materials analysis in this particular example. We worked very closely with industry, and they provided for us the information we needed related to the performance of the fabrics that we were interested in using. We did visit construction sites, observed carpenters at work, looking at how they moved, where they moved, the kinds of positions that they may find themselves in as they work. And we found that it was anything from kneeling on the floor to sitting to laying down on the back to be under a cabinet or a counter to climbing up a ladder. So a wide range of movement had to be accommodated. We conducted interviews both in groups and individual as kind of a follow-up, and looked at existing products. In some cases, there was very obvious flaws in the existing products that we could see definite places for improvement. And I'll show you those as we move into looking at some examples of the finished product. This is the grid structure, just to show you what it looks like. I know you can't read it and didn't expect you to, but you can see how customer requirements on one side, requirements for the product are across the top, and in the grid you can begin to see what's a positive relationship with a negative relationship and begin to weigh out how these trade-offs might work. This is the pant. You can see several shots of it. You'll notice there are double knees. The knees were one of the areas of failure that we found. The pockets on the side actually are three-level pockets, so they can hold several different kinds of screws and nails and have tool holders inside of them as well. There were multiple places to hook the hammer, which was a prominent tool. You can see also the pockets in the back with the flaps, so tools weren't lost when they were bending and moving, etc. So this is a product that's resulted from this process. We found that this process was very effective, really facilitated working as a team, allowing us to bring all of the inputs into the process simultaneously. Drawing from this combination of design approaches gave us a very disciplined, objective, and consumer responsive sort of design process. Drawing from that QFD tool really made it a very effective way to translate these requirements into specifications for the product and in fact into the end product design. We did find that figuring out the requirements was very challenging. It's not the case that carpenters or any consumer for that matter, in my opinion, can express everything that's important to them. It takes some expertise, and the observation was an important point. I also think that this process is very broad application for products other than apparel, as well as just functional kinds of apparel products. Thank you very much.
Thank you very much, Dr. May-Plumlee. It's interesting to see in practice how all aspects of design, technology, from fibre through to end user can be integrated, and to see an example of how this has come into practice. I can't see the audience because the lights are off. If I ask for questions, I can't see if anybody would like. If anybody would like to ask a question, perhaps I could come to the front and actually see them. Or would somebody like to switch the lights on at the back?
Yes, please.
If you come to the front, if you can find your way to the front.
Thank you. Thank you for your good presentation. And I would like to ask about what you mean by analysis for the carpenter suit at the review. What do you mean by review? Analysis for the trouser for the carpenter. There is 5 things I think analysis. The third step, review. What do you mean by review? Yes. Yes, interview, yeah.
Okay. Interview, what I mean by interviews is actually sitting down and talking to carpenters who would wear the product and use the product and ask them about the kinds of things that they do on the job, the kinds of concerns they have about the products maybe that they're already using. These particular ones I did both by talking to groups of carpenters and then individually, one-on-one, particularly if there were questions that came up as we were developing the product.
Is it similar to analysis of the body, something like
The only similarity it has to analysis of the body is that in both cases you're studying the end user. Analysis of the body is more observational, that you would watch and observe. Interviews are more conversational, that you would talk and ask questions and discuss.
ask question for the one who is using the project?
Right.
Oh, thank you.
You're welcome.
Okay, thank you very much.